welcome everyone. As Ksenia said, I'm co-founder and CEO of Hypi. It's a backend as a service platform that we've now included low code and a bunch of serverless functionality in as well to meet customer demand. So as I said, I'm Courtney, part-time PhD student, and I have a deep interest in distributed systems. My part-time PhD is in looking at the correctness of distributed systems, and my thesis is actually based around Apache Ignite and some of the things that I've created as part of that PhD to help with correctness, basically. So what does Hypi do? What do we do in general? And instead of trying to give a long worded explanation of that, I have a few pictures to show you to try and help answer that question. Hypi lets backend as a service platform that we've had for a few years now, lets a developer start with something like this, just providing a simple name, and then going in to designing their tables that they would like to have in their application. And then within a couple of minutes, they can start working with it by using the APIs that are generated from that. That's as short as I think I could describe what the backend as a service platform provides. Now, this whole process of going from your app name, your ideas, to your actual live API is a functionality, or the entire feature set is built on top of Ignite. So when a user says, I would like to create a table, like here, for example, these are actually in the background going to be generating Ignite columns in this. We're using the SQL API for a lot of what we provide. So these are actually mapping to SQL tables in Ignite. Now, for a while, for a long while actually, that was enough. The bulk of our customers are professional developers, so they've done software development professionally, and basically that's their full-time job, right? So we've provided the backend as a service to help them remove the repetitive parts of development for them. So no more CRUD operations. Think about how many microservices or other services you've written, and how much of those ended up with CRUD code being rewritten and copied, reused elsewhere. The same thing for authentication, authorization, and other functionality. Hypi includes all of those out of the box. Simply in those 3 steps that I showed you earlier, at the end of that, all of that goes away. So no more need for you to write CRUD code, no more need for you to do authorization and authentication yourself, and a bunch of other functionality that the platform itself provides. And this served us well for a while. But increasingly, the developers or the customers using the platform, they liked the visual approach that we took to this, and they kept asking for more ways to customize the services that they were building through the browser, basically, because it's available on the web. It's a cloud service. And that led us to what we're about to launch in the coming months. Now we're integrating an open source UI builder into the platform. So on top of the backend as a service that we've offered for years, we're about to launch this low code part of the platform as well that will allow a developer to visually create their application, both the backend and the front end. So one of the things that will mean is that the person doing the development doesn't actually need to be a professional developer anymore. So you could be, if you're a professional developer, it's a way for you to speed up your development lifecycle, but you no longer have to be a professional developer to take the backend as a service APIs and turn that into a functional application that delivers for the business you're working for. Now, Hypi's been growing and adding these functionality to meet customer demands. And what we've had whilst we've been doing this, so as well as the visual extensions that we've been asked for, people have consistently been asking, can they have machine learning in the platform as well? Now, this has been an interesting question for us because we know that Ignite includes machine learning functionality, and it's something that we'd originally intended to include in our APIs as well. Now, the challenge we had was, how do we go about presenting that API to the users so that they don't have to know Ignite. They don't even have to know that it's powered by Ignite to be able to use them. And the first challenge we found was actually when we started speaking to customers and we'd ask, for example, the managers, what is it you want to do with machine learning in your application, in your business? And in general, you would get these very broad kind of magic wand type requirements. And it became very clear to us that a lot of people had expectations for machine learning to deliver things that were just not realistic. And on the other spectrum, we've got the developers from the same businesses that we speak to, and they'll tell us, hey, we just heard that XYZ open source this model, and we'd like to use this in our application. But at the same time, these tools that are being open source doesn't quite meet the requirements or match what the managers are asking for either. So before we even got started trying to add machine learning into the platform, we had a problem, right? And that problem was the expectation between both the developers and the business didn't quite align with A, what was sometimes possible, and B, they didn't agree with each other as to what exactly they were trying to deliver. So that was the first problem we had out of the gate, trying to decide how do we go about presenting machine learning capabilities in a low-code way. All right. So the other problems we tended to come across was that most of our customers are smaller businesses. We do have enterprises as well, but we've got smaller customers who they can't, in some cases, afford the top tier salaries that they would need to hire top-notch machine learning or data scientists that they would need to build some of the things that they're talking about. The other thing is that a lot of them don't have the volume of data that would be needed to train a good model to fit the use cases that they're trying to create. And so on top of that challenge I mentioned earlier, we had to go about trying to basically bring everyone down to earth and set expectations for what exactly they will be able to get out of this. Now, before we do that, one of Hypi's founding principles, the reason we created the platform in the first place, is to try and basically help developers, and also businesses that don't necessarily have the expertise in modern technologies to be able to take advantage of them without having to become experts. In some cases, becoming an expert can take years to get to that point, and machine learning is no exception. And I think for many people, it's probably even harder than some other tech to really become an expert in. So before we move on, let's take a step back and have a look. If you look at the diagram on the right, what this is showing, well, according to Google anyway, is the typical life cycle of machine learning development project, right? And this one's split out into 6 phases. Now, what we found after going through our analysis and speaking to different customers is that actually everything that is needed in this process, more or less, is actually on the platform side. It's something that we have control of as the platform provider. And that comes with some perks, because it means that if we hire machine learning experts, if we provide the machine learning capabilities in a simple, we hope, way, then that would mean they don't need to go through that. They don't need to hire experts. They don't need to hire expensive data scientists or developers in order to meet some of the needs that they have. And so as we went through, we picked out, or rather identified, a couple of problems. I mentioned these earlier, but one of them that was kind of implicit in the things that we'd identified is this one highlighted in red, where even if we presented the machine learning APIs to the developers or to the businesses, in many cases, a lot of them wouldn't know which ones to use, when to use them, or what to use them for. As I mentioned, these are businesses who they are not, their core business is not tech, right? So they're trying to use the machine learning technology to add some value to their business, but their core business is not tech. And so they don't know which of these to choose. So a bigger problem that we came on to later on as we started working through some use cases with some customers. Now, Ignite itself provides a wide array of machine learning algorithms, and it also has integration with TensorFlow and Apache Spark, which itself actually also has the Spark machine learning implementation available as well. So there's a wide array of options to choose from, but actually deciding which one could pick and how we go about educating our customers as to which ones they would use and when it still is actually a challenge. At the moment, what we've done is we've taken the wizard approach. So you don't necessarily have to be an expert. And we allow you to tune the algorithms that you've chosen without having to write any code. But there is still more work we recognize that needs to go into helping them to identify when they want a particular algorithm. Now, we've taken a use case-based approach to this. We've started out with a handful of customers that were initially kind of leading the charge, asking for machine learning in the platform. And what we've come up with is a set of case studies, which we're hoping to expand on over the rest of this coming year, basically. Now, in the platform, more or less everything is currently visual. On screen is the new machine learning interface. So if you were looking to create a machine learning model in Hypi, you deal with instances. It's a multi-tenant platform. So in this screenshot here, you would have to select your instance, which contains your data that you would like to do your training on and eventually use the APIs against. And then you need to go through and choose effectively which algorithms you want to use and tune them by providing the parameters. Now, this is the part that I said we still need to do some work on, because if you recall, I said earlier that actually many of these customers don't actually know when they would choose a particular algorithm or approach, and what best suits a particular use case that they might have. So right now, we have made some progress in getting them access to machine learning and machine learning on top of Ignite. So if you're familiar with the Ignite APIs, actually on screen is more or less a one-for-one mapping with what Ignite currently provides. And all the users have to do, I say all, but actually for non-technical businesses, it's quite a lot. What they need to do is tune the algorithms by providing and customizing the parameters that that particular algorithm supports. And for this to help them, we generally try to have one-on-ones with the businesses that we know are looking to do this, that do not have machine learning expertise. So we'll help them to choose which ones might solve a particular problem for them. And then the other thing that we help them to do is machine learning is one thing, but after you've built your model, in many cases that we have from our customer base, actually what they need isn't an API or some model that they can use for something else. What they want is some way of taking action based on what's happening with their data. And so once you've chosen your algorithms in the platform, what we allow them to do is we have a number of different visualization widgets that we allow them to then choose. Hey, let's say, for example, on the next screen, where we were working with a customer that's got actual temperature data. In this case, the visualization widget allows the customer to say, all right, I'm going to highlight a section of my graph. And once I've done my training, once I've set everything up, if any events come through that fit into this cluster, then I want to know about it. Excuse me. So I want to know about it is the interesting part for the customer. They don't really know or care about exactly how it works underneath. They've just said, when some of my data falls in here, I want to know about it. And on the right, you can see there's just a simple drop down for them to select a function. And Hypi, a part of the platform, you've got serverless capabilities built in. And so on the right-hand side of the screen, what they're able to do is just say, all right, when one of my data points fall within this cluster, I want to fire this serverless function. And when that serverless function gets fired, it will get passed the context about the data that's triggering it and a bunch of information that they can then use to make decisions. This is actually, for our customers, really powerful, because what it now means is that actually the developers that they were using, sometimes, in many cases, actually, they're outsourcing their development. And so the developers that they've been using to build and maintain their applications, they can continue to do so. They can continue to use these developers because all the developer has to do now is write some code in whatever language they're using. The serverless platform we use is OpenWhisk, which supports, I believe, about a dozen different languages and platforms. So you pick your favorite language, and all they do from the user interface is select a function. When an event falls within that cluster, that serverless function gets triggered. And this actually meets several use cases and have been used for things that we actually didn't even think of when we were designing it. So Hypi is taking a step towards trying to effectively do low code on top of machine learning in a slightly different way, because there are several providers at the moment that will allow you to do, you could potentially call it low code even for machine learning, but they still have a relatively high bar for you to cross in order to start using that functionality. And I think the key for our customers here is, as I mentioned earlier, they can continue to use their developers that have no prior experience with machine learning to build out this capability and start taking advantage of those in their organization. Now, I mentioned, and I've highlighted it here again, that we're still looking at ways in which we could reduce how much knowledge is needed for a developer to actually get started with these. If you saw in the previous examples, you still need to have some understanding of what those parameters are, what they do, what effect they have on your models, and ultimately what they're controlling. So we're still looking at ways in which to try and reduce that barrier even further. But for now, this has been a relatively good start for many of our customers that machine learning was previously inaccessible to. So one of the things I wanted to do today was to take you through one of our larger customers, actually, that we're working with. And these guys, it's a couple of hospitals, and I was trying to get authorization to use them as a use case in this talk, and I didn't end up doing that in the end. So I had to actually change my presentation earlier, a couple of days ago. So what I can tell you is, at a high level, what the research work is and what they're hoping to achieve. And I'll talk to you a little bit about Hypi's architecture and how some of this maps on to the APIs that Ignite provides. So the use case itself is COVID-19, because, you know, pretty much what else is there since the last 18 or so months. Now, what they're doing specifically is they're basically taking images that were taken of patients with COVID-19, and the hospitals, they know the eventual outcome of those patients. So what they're trying to do is look at the imaging data. There is some machine learning involved, and this is the part that I wanted to get into details about what they were doing, but I'm afraid I'm not allowed to. I'll talk about something else shortly, but they're looking at effectively trying to understand what difference, if any, exists between the patients that effectively ended up having a fatal outcome versus ones that didn't, and trying to identify what risk factors were included that potentially influence the eventual outcome of those patients. It's an interesting use case that I hope I will eventually get authorization to talk more about, and we'll potentially do that in the London Ignite meetup at some point. For the rest of the slide, what I'm going to tell you about is a separate customer that have they're basically a mini social network that helps their customers to improve their nightlife. So their use case is that excuse me, if you went out on for example, a Friday night, and you plan to go to some bar, or for example, and then when you got there, it was closed, or even you were there, but you decided you wanted to go somewhere else. It's not necessarily easy to find a good place, a good next place for you to go to. And so they're trying to effectively help their customers to find good places when they're out, either planned or not. So before we move on, I'll talk a little bit about the Hypi architecture, and then I'll explain about how these guys are using the platform to achieve the use case I just described with this kind of venue discovery. Hypi itself, we've been around for, I think, several years now. So we've been around for several years now. So the platform has grown, and at the entry point to the platform, we currently support, I think, 4 or 5 different ways of getting data into the platform. And these all are working with different Ignite APIs. I'll talk a little bit about what those are in a second. But at the center of our platform is actually GraphQL. We're very GraphQL centric at the moment. And this GraphQL API that everything kind of funnels into is what allows us to do some of the things that I'm about to explain to you. So the particular customer in mind, one of the things that they need is real-time information. And for that, GraphQL supports subscriptions. So we have WebSocket API support, where their user app, so in the mobile app that's connecting to the API we generate for them, is connected via WebSockets and will then receive some notifications. That's one example. The other example is to interact with the CRUD API that Hypi generates. I alluded to this earlier. That is the, I guess, regular GraphQL API. But on top of that, we also support, I guess, a normal traditional REST API. And we also support file uploads. Like this social application, for example, allows their customers to upload images of the venues that they're at, and to upload videos, like short reels of what's happening in the particular venue. And use cases, I mentioned Hypi is deployed in a wide number of scenarios. One of them is in our enterprise cases. We've got customers that are using streaming technologies like Kafka and Pulsar, and so we've also got support for these as ingestion points. Now, we have several capabilities in the platform, including things like authorization, that pretty much everything has to go through before actually getting into Ignite. So on screen, if you look at the bottom left, I know there's quite a lot going on in the bottom left, but effectively, if the platform has at its core event handlers. So if you imagine Pulsar data comes through, or GraphQL data comes through, wherever the source is, it first goes through the GraphQL engine, which will then look at the request and decide where it's going to be routed to. And where it's routed to is a number of event handlers. These event handlers can go to, for example, Ignite itself, can go to Lucene. Actually, we've changed that. We've now migrated to Solar for full text search. And the serverless functionality that I mentioned earlier, we previously supported both OpenFaaS and OpenWhisk, but OpenFaaS has been deprecated. So now we're solely focused on the OpenWhisk serverless functionality. When data comes through, the event handlers using the GraphQL libraries that we've got will handle and process those requests. And one of the things they do, as I mentioned earlier, is authorization. The authorization controls are relatively complex in some cases, depending on what you're trying to achieve. But you can do anything from simple role-based access control all the way up to enterprise-level authorizations and fine-level permissions for each object. It's entirely up to your use case as to which of the APIs you choose to use to be able to achieve that. I'm going to move on from the architecture, and I'll talk a little bit about how these guys in particular are using these APIs on the platform to achieve what I just talked about. So the platform, the cloud version is multi-tenant, which introduces some challenges with the native Ignite APIs, which out of the box are not. And this is especially true for the machine learning APIs where we've got the TensorFlow integration. And what we had to effectively ensure was that if a user has their instance and all their data in their instance, and they decide, hey, I'm going to do my training using the wizard that I showed earlier, they configure the algorithms that they want to use, put in the parameters, etc., and they start training, that the training is actually only done on the data in their instance. Now, we have multi-tenancy support at several levels. One of them is the instance level, where you can create an app, and in that app you have releases just as you would in your traditional development lifecycle. And from each release, you can create an instance. The difference between releases is largely schema differences. So if you wanted to migrate between release A and release B, that's usually why you would have multiple releases. But you would have multiple instances if you want to separate your data. So if you had, for example, let's imagine in these guys' case, they've only got one instance because of the nature of their application. But imagine they wanted to, they've built this app and they want to resell that to a different provider, in fact, who would be a competitor. They can then say, hey, I want to create a new instance, and that instance, the data within it would be completely isolated from their own. So they can completely reuse everything that they've built, resell that without any additional work. Now, when it comes to Ignite and the APIs that are available, the challenges we faced was that outside, at the point where we can filter the data that's used for the training, we don't have the authorization context that's necessary to be able to filter out which data belongs to which instance. A simple way, and in fact, how we ended up doing it in the end, is purely basing everything on the instance ID, because that's really the only information that we needed. But it then meant that we couldn't make our machine learning offering any more granular in terms of you wanting to be able to build modules on a subset of the data. We're still looking at different ways in which we can do that. And one of them that we're looking at is using Ignite Compute to go fetch the authorization context and then using a compute closure to filter that data with the context in hand to be able to do better authorization on that. That was the first challenge we faced. We faced this not just in the social network, the social app use case, but also in the COVID-19 example that I mentioned earlier. For various reasons, some of that data requires authorization. And so we had this problem in that case as well. The challenge there, again, was overcome by finding some good identifier that we could split everything out on. The Hypi APIs for doing the machine learning, once you've finished your training using the wizards that I showed earlier, what you end up doing is Hypi generates this endpoint for you where you can do predictions. So in the case of the recommendation, for example, we'll have a recommendation API that's generated, and the user's app then calls in and says, hey, this user's at this location, and they do a prediction based on data that a model that they've trained previously. And once they've done prediction, they're then mixing the results of this with the serverless capability to then say notify users of what's considered a hotspot, right? So if a particular bar or restaurant is getting lots of traction on that night, for example, they can quickly identify many of those and then basically send out notifications to other users and just let them know that this particular restaurant is going wild, they can go there or whatever. The integrations from Ignite into OpenWhisk was interesting for us, and it's related to the filtering that I mentioned earlier. But because we have these event handlers where in GraphQL, they're effectively completely disjoint. So if we wanted to communicate between them, what we ended up having to do was to use Ignite to use the Ignite messaging APIs to send messages across them. So within a single request, let's say, for example, in the case where they want to notify users, that has come off the results of a prediction saying that the user falls within some requirement, right? And the user set up some trigger that calls a serverless function. So internally, we're using the Ignite messaging API to fire off these events within the cluster that will then trigger, for example, the notification using some external services that will do a push notification over to the user's phone. So in all of this, Hypi maps the backend as a service API that we provide onto the Ignite caches SQL tables because we largely use the SQL API for a lot of this. The event handlers will then, in the current implementation, seamlessly combine the results from Solar with the results from Ignite. So actually, to say it's combining isn't quite right. The query will first hit Solar to find a reduced subset of data that matches some advanced query that we're not able to express either in Ignite or in Ignite SQL without doing, for example, some custom filtering, etc. So we use Solar as the entry point for certain queries. And we have a DSL that allows users to be able to express that Solar query to match on their data. And then the results of those are then what we push down to Ignite to then do further filtering, because we're only storing a small index in Solar, right? So the actual data itself isn't there. And then we push that filter down to Ignite, and the resulting data from Ignite ends up being what the user actually needs. That will get pushed out, in this case, in this customer's case, over WebSockets for them to do their notifications in-app. So to wrap up and close off, Hypi has been using Ignite now, I think, for 3.5 years. And in general, the rich APIs have allowed us to continually broaden the feature set that we provide to our customers. And the product has evolved from what was a plain backend as a service platform into now having both a low-code visual builder that is also then being mapped onto Ignite, as well as the machine learning capabilities that I've just alluded to in the second part of this presentation. The other part of it is that our customer base is quite varied. We have a cloud offering where anyone can just go sign up, use, build their app. And we also have an on-premise option where you would basically get some containers, and we require Kubernetes cluster. We run Ignite and the rest of our services in Kubernetes. But you would get all of our binaries all over the containers effectively, deploy those in Kubernetes, and you effectively got the same service that we're running in the cloud on-premise. And because of Ignite's flexibility and being able to blend into all of these different environments, we've been able to serve both small customers, as I mentioned, that don't even have the expertise to be able to do anything on premise, to large multinational enterprises that have their own team dedicated just to the product to build their applications. I think in closing, what I want to say on that is that it's a very flexible platform, very diverse and rich set of APIs. In some cases, you might have more APIs than you're able to know what you're supposed to do with. And it's been a very interesting platform for us and for our customers eventually that this gets passed on to. So that's it for my presentation. Ksenia, I think I'm about 10 minutes early on that. Do we have any questions?
Yeah, we do have a question. So you mentioned that one of the challenges is to get big enough data sets for training. How do you tackle this problem while working with your customers? Do the models perform well even when little data was provided for the training?
Right. So this we're still having ongoing work to try and solve this. For the customers that really have very little data to be able to do this, we're currently investigating how to effectively apply. I forgot what it's called. And I will say one caveat here is myself. I'm a developer professionally for over 10 years now, but I'm no machine learning expert, right? So our team has educated me on a lot of this. And they're currently looking into what's called transfer learning. So basically, where we'll go around, we'll take models that others who have lots of data have built, and we provide APIs to our customers that require a smaller sample of data to be able to achieve basically relatively useful outcomes from their models.
Thank you very much for your talk.